so the thing that really intrigues me is the use of formic acid, and I had to Google that, or in this case Wikipedia, because I thought, I have no idea what formic acid. I mean, when I hear the word acid, I start to get a little nervous, right? Because generally you don't want to be around things that are too caustic and can burn you and so on. So first of all, what is formic acid, and how can you use formic acid as a fuel source for a fuel cell?
Well, great questions. Formic acid is one of the weakest acids available. It's safer than diesel and gasoline and from a handling, flashpoint, a variety of other metrics that are typically considered. Formic acid is the little sting that you feel when you get an ant bite. The ant is injecting a little bit of formic acid into you. So that's why you get a sting. You feel the sting when you get an ant bite. Formic acid comes, among other things, is produced from ants, but it's a very biodegradable, a biomass-generated fuel. It can be created from a variety of renewable resources. It's a very low-cost commodity chemical that is used for a variety of to create a variety of other chemicals, plastics, things like that. So it's a very widely available chemical.
Well, yeah, the thing that I notice is that it's put on silage. And of course, if you're familiar with the Midwest and all the corn we have around here, that's one of the ways. That's what you do with a lot of the corn crop around here is you take and make silage out of it to feed cattle with, and sort of, if you will, the preservative that they put over that is formic acid, I understand.
Yeah, so I can't comment specifically on that. I'm not an expert on the preservative elements of formic acid, but you're making a very good point that it's a very commonly used chemical. We don't necessarily think of it as formic acid, but it's used in a variety of applications.
Right.
Typically, the formic acid can be produced from a variety of sources. It's a commodity chemical, so it's available at very low cost, under $1 a gallon of formic acid. So it's available from a variety of sources. What's very attractive, you made the point about methanol being considered as a potential fuel for fuel cells. The beauty about formic acid, and the reason we made the acquisition back in November 2013, is it's a very simple molecule. The formula is HCOOH. So It's got very few linkages. So it's a molecule that can very easily be dissociated in a fuel cell. Fuel cells take a molecule and tear them apart, what's called electrocatalytically, meaning it's at a surface, it dissociates the molecule. So the more complicated the molecule gets, the more difficult it is to realize the full energy that's in there.
Right.
And formic acid, again, it has the formula is HCOOH, so you've got two hydrogen atoms in there, so that is what acts as a fuel. The nice thing, the differentiation in formic acid compared to all other liquid fuels, again, for the reason being how simple the molecule is, we can use more than 90% concentrated formic acid, so the fuel is very energy dense. Typically, if you're using methanol or ethanol or propanol, longer chain molecules, you're typically adding more water. So methanol is typically used in a 60% methanol, 40% water combination, because you need the water to do certain to serve certain functions in that chemical reaction. So it's not the most efficient. So the most energy dense, the energy per unit weight or unit volume, in our view, is formic acid is the most attractive solution. It's obviously safer than sitting on a rocket, as you were discussing earlier, in terms of compressed hydrogen, but it's more energy dense because you can only squeeze the gas in, whereas in this case you're using a liquid that you're operating with. I made the point earlier that formic acid is easier to handle than gasoline or diesel. It's effectively like a household cleaner. It's got to be treated with the same level of respect. as a household cleaner.
Right. Well, I
Yes.
guess my concern would be is that this is something where I have bleach in the house here and things like that. How safe is this to actually for a person at 90% concentrate? How safe is that for a person to handle? I mean, I use gasoline to clean up my hands,
Yeah.
after painting or something
Yeah.
like that. I don't mind that, but I'm not sure I want to, can I get by with, I don't want it in my eyes, obviously, but
Yeah.
will it
We,
burn my
we, we
skin?
don't
Or
yeah. We don't recommend cleaning your hands with formic acid, or for that matter, cleaning your hands with gasoline.
Right,
It's no different than bleach or any household cleaner. If it gets on your hands, you wash it off underwater, and that's it. If you immerse your hand for extended periods of time, you may get some discoloration, and we obviously do not recommend doing any of that. But to the same extent that you would treat either bleach or any household cleaner, you'd want to be treating this the same. We're
okay,
kind of giving it the same respect as that.
okay. Well, let's,
And
let
like I said, among all the acids, it's one of the weakest acids. So the corrosiveness and others are orders of magnitude less than other acids like sulfuric or nitric acids.
right, right. And we use sulfuric acid in our
Yeah.
batteries and things like that. Can you walk me through the Reformation process here?
Yeah.
Because obviously you can't use that directly, as you point out. You have to take and break those molecules apart so you get to the hydrogen. So kind of walk me through, because that's what you've actually acquired is a reformer technology, right?
Correct. So this technology is covered by two patent applications. We actually have some of our lab samples here. So this would be what the typical 100-watt reformer unit is. So this is about, just for reference, it's
Okay.
it's kind of hard to see, but it's
About
about
9 inches.
little over 6 inches.
Oh, okay.
And a lot of this is primarily the insulation. So what you're seeing inside is a system.
Right.
This unit would run at about 170 Celsius, so that's why it's covered on the insulation.
Okay.
Typically have two micro pumps like this
Okay.
to push the formic acid through the system, another pump like this to blow the air through the system, and what you get out of it would be the hydrogen.
Oh, okay.
The hydrogen from this system, so this is a 100-watt system. The hydrogen from that system would typically flow to a stack. This is a 50-watt stack. And I'm not sure you can see that very well, but this is
that's where the hydrogen will go in.
So you run hydrogen in through this. Hydrogen comes out at the other end, and this fan blows the air across the pen. So that's what causes this system to then generate electricity. The electrons are collected at this point.
Okay.
So that's effectively how the formic acid reformer technology works.
Okay.
Beauty about this is for automotive applications, for a pure play fuel cell, you typically would go into the multi-kilowatt, high tens of kilowatt area. But in our view, the best solution would be a hybrid of a battery and a fuel cell, because it leverages existing battery infrastructure and capability. And then this fuel cell would typically act to keep the batteries trickle charged. So, for example, if you've got 10 batteries, you may shrink that down to 5 or 6. And then while 3 batteries are driving the vehicle, the other 3 are being trickle charged by the fuel cell.
Oh, okay.
Just keep alternating that way.
Right.
So we had some preliminary discussions. We can't get into details about the auto manufacturers' names, but we've got some preliminary discussions there. Obviously, there's scale-up issues, but one of the nice things is we could just have multiple units of this, so you've got redundancy, or we could scale it up and build larger systems.
Okay. Well, that was one of the questions I had, was how scalable is that? Because obviously you're going to need typically anywhere from 80 to 100 kilowatts to effectively drive a large automobile.
Yeah. Yeah, so again, it may appear that we've got a very disparate product offering, but the formic acid is what goes into the buzz cell offering for the consumer product. And in our view, what we are looking at doing over the next 1 to 3 year time frame is partner with automotive manufacturers to really leverage our technology and their manufacturing scale-up abilities to define the products to meet their custom needs.
Right. Well, just
Yeah,
I was going to say, just thinking about it. Of course, like with anything, whether it's be natural gas, whether it be hydrogen, whether it be methanol or ethanol, it always comes down to the issue of infrastructure.
correct. Yeah.
Where do you get that now? Go back 100 years or so, and gasoline was, you had to go to a drugstore to buy it, right? I mean,
Yeah.
it wasn't readily available. I could see somebody going to a CVS maybe or a Walgreens and say, "Can I have a few liters of formic acid?"
Yeah.
We may get to the point to where the infrastructure is there, but that seems to me is kind of this type of technology. It seems to me sort of really readily adapts itself to initially to a application, for example, like fuel cell forklifts, where they've got a closed operation environment. They've got the sources where they can put the tanks and things like that, or on an electric bicycle, an electric motor scooter. Those kinds of applications would seem to, in my mind at least, work a little better initially.
Absolutely, and I think from that standpoint, we are looking at these type of applications, whether it is a drone application, an off-grid sensor application. You've got one consumer of the product, and they've got the logistics and supply chain to be able to get the formic acid to their product, whether it is a drone or an off-grid sensor, for example.
Right.
You're absolutely right that longer term for automotive implementations, right? We've got to partner with the larger companies to be able to do this. One of the nice things about the formic acid technology is that we believe we can repurpose existing gasoline distribution infrastructure to distribute formic acid as well. Today, with compressed hydrogen, there's a variety of studies, including Department of Energy reports that talk about each state of the union having to spend $20 billion or so to put in an infrastructure to distribute hydrogen.
Right.
So while this is not for automotive applications, this is not a solution that you're going to see in widespread adoption in 1 year or 2 years. But it's at the time that, from a discussion standpoint, this is one of the very differentiated technologies that should be considered as a viable option.
Okay.
Remember that we are not talking about redesigning the fuel cell itself that is in cars. Today, if you're using a PEM-based fuel cell or if you're using a solid oxide fuel cell, the hydrogen that we generate with this system can be used for any of those existing fuel cells. So as an alternative to compressed hydrogen, this is a safer way to deploy hydrogen into the marketplace.
What happens to those? I was going to say, what happens to the other molecules? You've got it looks like carbon monoxide, and you probably have some what other?
So when you react the formic acid across this electrocatalytic surface, the byproducts are typically CO2 and water vapor and electrons. Electrons make up the energy. The byproducts of carbon dioxide are orders of magnitude less than the equivalent combustion and the concerns raised with global warming relative to gasoline and other combustion processes. It's a much cleaner, much more efficient process.
Yeah, and especially if your feedstock is coming from wood pulp or something of that nature. It's a zero amount of CO2 that you're actually